load impedance because we're going from the load to the generator. So we're basically backtracking that way. So toward the generator is this way, and
Yep.
toward the load it's this way when we're turning.
Jedna sekunda.
Nie mogę, przepraszam.
Pytanie.
Jakie pytanie?
Czy w sobotę wolisz o 4 czy o 5 pójść na obiad?
Można o 5.
5?
No tak. Sorry about that. It was a quick little question I had to answer. All right, so basically,
No, you good.
yeah. So the first thing we need to do is normalize our impedances because we actually have to graph them on the Smith chart. I'm not going to be graphing 100 plus 200. I'd rather graph 1 plus 200 or whatever. Well, I mean, I have to divide by the impedance, so we have to
Yeah, you gotta
basically
divide by-
take our we basically have to
Alrighty,
divide
so
by our load
what
impedance.
what is it that's given to us in this problem?
Basically,
Yeah, go ahead, Michael.
oh no, basically all this is given to us, so we're just gonna have to. They're gonna basically say like find Z in, like for example, and Z in is like the impedance at the generator, and so we have to go from here. Like we're given all the load impedances, and so we have to work our way to the generator.
Yeah, so
Okay.
just to keep your everything 100% clear. The Z impedance L1, you're given 100 plus J 200. Z impedance 2, you're given 20 minus J 100. You're given the
Yes,
lambda
sir.
over 4. You're given the 50 ohms, and you're given lambda over 6, and then all you gotta find is Zn. Yep.
Yep, that is what I'm given. Awesome. And then basically we're just going to divide this by 50, and this will give us, let's see, minus J2. All right, so now this is the part where we have to actually use the Smith chart. And so
Yep.
we're going to have to take this one by one. So we could first start with this one. I'll probably change colors because, it'll be better this way. All right, so let's probably start with this first one. So ignore my very poorly drawn Smith chart. Let's just imagine the point is somewhere over here.
No, I got you. I'm actually gonna do the Smith chart actually right now as you do it too.
All right, that's a good idea for sure. And so now what we're given is we're given lambda over 4. And so what does that mean? It means, first of all, we have lambda over 4. So that would be 720 degrees over 4, which would result in, what is that, 180 degrees? So that would mean we have to go, and because we're going from here and we're moving in the direction towards the generator, we're going to have to be turning 180 degrees this way. And so whatever that is, I have no idea, but I'm going to have my median, my needle's going to be at the prime center right here, and my compass is basically just going to be rotating somewhere over here. I'm just going to pretend that's 180 and it's somewhere here, and I have some impedance. I don't know, Will, if you have an actual number or not, but
Yeah, so it was lambda over 4, right?
yeah.
Okay, so let me do 720 divided by 4 on my calculator. That's 180, so I got to make a 180.
Yes, sir.
Okay. I do my math right here. I'm at one. Shit. Oh yeah, that's gonna be tough.
So the blue point on
How did y'all
top,
feel about that final
that's the
exam
2 plus
for 360?
4J.
Yes. So that's basically this guy is this.
How did y'all feel about
I
that?
passed it. It's this, and this second blue point. I'll make it green actually. Why not? This is essentially our. This is like our new. From basically.
Oh, okay. After rotating it 180 to 180
Yes, sir.
towards
Correct.
the generator.
Yeah.
And
Awesome.
why is it going to the generator?
Because we're given the values of the load, but we're trying to find the value at the generator. And so in order to find the value at the generator, we have to do math basically at the load, and we have to progress our way towards the generator. It's kind of like, you have your like you have a circuit, right? And you have like a bunch of resistors in parallel, and you're asked to find the voltage here. Well, you're going to want to start by combining all these guys first, and you're going to work your way here eventually. And so that's what we're doing with this essentially.
Oh, okay. Awesome.
And then I'm not 100% sure. Is it that when we get our two new points, after we say, so we plot this guy, and then we also have to do the exact same thing for this guy. Like we plot a point somewhere, and then we also have to rotate 180 degrees towards the generator, and we get some new point. Is it these two new points that we add and combine in parallel, and then we renormalize it? Or how does it work?
I'm 90% sure that's the case. I think he just chose a really bad example when he was doing it, and he just made it so it's like, oh, look, they both go around 360, so we don't have to worry about anything, and then didn't actually show us how to get the actual new values.
Is this from the book?
Somewhat.
Example?
This
no.
is from class, like when he did the review lecture. These are like the exact numbers he used in the review lecture.
Yeah. Oh, and by the way, I try to do the estimate. So when I did 720 divided by 4, when I got 180, so I got to make like half, do a semicircle. When I try to rotate it around my, I feel like this point we got to estimate because sometimes our compass is not 100% accurate. Well, at least I did it inaccurate, I feel like. But the closer I got to have like an easier number, I got like 0.5 on the real, and then for my imaginary, I got a 1.
Okay, interesting.
So like half, boom. I can show you how I did it.
Which
Yeah,
chapter is this again? Chapter 10, right?
11.
Chapter
So,
11.
11? Okay.
Mm-hmm.
Can
Okay.
y'all see my screen?
I think it's
I'll stop sharing.
11.5 more specifically. 11.5. That's the section for that, I believe.
Yeah. What's up? I got some new faces in here. That's great. Hold up. Y'all can see my screen, right?
Yeah.
Yeah,
Okay.
I see it.
This is how I did it. So my origin was out the 1 right here, and then I this is what the value that we had given what Michael says. So we had like 2 right here, and this was 4. So I rotate all the way here. I kind of got off the mark right here, but this is where I kind of ended because it looked like a 180 semicircle. So I would estimate it would have to be somewhere around here. Okay. So this would be 0.5, and up here, this says to be 1. I think it just.
Yeah, we're gonna really have to be careful with doing the numbers in the Smith chart. We'll really have to follow the angles on the perimeter of the chart just to like make sure we're not too far off because our eyes could be deceiving sometimes.
Yeah, the one thing I can say is that that's why I got one of those angle measure things where, like, you know how it's a half circle and then you can just kind of put it on your page and then like find the start of your point and then you can just trace it along.
Yeah.
Those are very useful.
Protractor.
Yeah.
Yeah, protractor would be nice, but
I don't
yeah,
have one. Oh well, that's fine.
yeah.
Well,
Y'all can just sit next to me and I'll we can share.
I'd be so down.
Yeah, we're not cheating.
Yeah, why don't you guys just sit at the front of the class? I'm all alone.
Yeah, I'll probably have to go upstairs because I'm gonna use my DRC thing again because he wants me to be in his office instead of the DRC.
Oh, you're part of the Democratic Republic of Congo?
Yes,
Oh, okay, cool.
I love me some mangoes.
All right, for sure. So that would be for that one then.
All right. So basically, what we have now, so we are first of all given these parallel points. So what we have, so let's just say we have, you know what? I'm just gonna make some random numbers up. So let's just say after the Smith chart, let's just say this. So after the Smith chart, our ZL1N is now all of a sudden, I'm gonna call it prime. Why not? Let's just say it's I don't know, 4 plus J, and our other one is, I don't know, let's say I don't know. You guys come up with something? All right, fine. I'll just say 3/5. I don't know, plus J2. Sure. Let's just make random numbers at this point. All right. So afterwards, we need to, because we're taking these in parallel, before we can renormalize it, we need to add them. And so that's probably what we need to do. So because it's in parallel, add before multiplying by 50 ohms. I think that's the way. If you could always correct me, Thomas, if you think I'm wrong. But
Sorry,
I'll
could you
just
say
keep
again?
going.
I was trying to figure out how the dipole problems work because I have no idea how a dipole works because we didn't do any antenna problems. We're gonna have one on the test.
Oh no, for sure. We'll go over that probably next. Honestly, I was just wondering, like, if I'm ever doing anything wrong, just let me know because I don't want to deceive anybody.
Okay.
For sure. So I'll just basically add them. So let's see, this 20/5 plus 3/5. So it's 23/5 plus let's see, 3J or J3. So that's the sum basically of L1 and 2. That's basically that essentially, the primes after you add them. So now basically we need to multiply again or renormalize it. So we have to go ahead and multiply by 50. So we're multiplying this by 50 ohms. And so now we're going to have, let's see, the answer would be, see, that would be 230 plus J150. And so this is our, I'm going to call this just ZL at this point. This is the ZL load. So now we basically simplified our circuit to this, or our, I call it a circuit, but this is a waveguide, I think. Yeah, so we simplified it to this now. So we have, this is our ZL right here. This is this guy. And we're still trying to find Zin. And we are now in another 50 ohm realm because we already dealt with this. So if this was, for example, let's just be fun and let's make this 100 ohms. Let's just make it 100 ohms, for example. So I'll change this to 100. And this is also lambda over 6. All right, so now we're given the ZL. This is after we did all the math with simplifying the loads and all that stuff. So now what we need to do is now to get Z in, we have to do the same procedure, but we have now ZL over here. We're going to have to divide this by 100 ohms.
Wait, could you? Okay, so back up real quick. What was the step you did before this? Like, did you? What I'm getting is you just added the two together, right? The two impedances from the parallel ones, right?
Yes.
And now you're going to the one in series, right?
Yes. So basically, I added them and then I multiplied by the 50 ohms again
Yes,
because
yes.
they
Okay,
have the
cool.
same. Yeah, yeah. So now we have our load, and I changed this to 100 because I wanted to change numbers just to make sure we understand the actual procedure. It's not just blindly plugging in 50 every time.
Mhm.
So we have 2.3 plus J 1.5. And so now it's the exact same thing we did before, where we're going to go to the Smith chart and we're going to plug it in. And now we're going to have to turn. Remember, we're still going towards the generator because we're starting at the load and we're going towards the generator because Zn is to the left of ZL. So we have to rotate 720 over 6 or 120 degrees this way. So let's say that this point is like right here, for example. We'll have to rotate 120 degrees this way to get a new point. Once we get that new point, we're going to go ahead and multiply that by 100 because we have to renormalize it. So this is our point. I'm going to make sure this is in red right here. So this is our new point that we have after rotating. So this is after the Smith chart. And so we have to multiply once again by our impedance. So we have 100 ohms times some number. Let's just pretend it's 2 plus 1J. Therefore, your Zn is just simply, it looks like, let's see, 200 let's see, 200 plus J100, and that would be our answer. It looks like. If that seems like a reasonable way to approach this problem, then this is what we should do on the test. If I did anything wrong, and if you guys would change anything, please let me know.
Yeah, I
So,
think that's about as good as we're gonna get.
for
Okay,
sure. Can you scroll up really quick?
for sure.
Yeah. The
Yeah,
procedure
so
easy. It's just the Smith chart is going to be the problem of how to like getting the values on there.
yeah. So after the Smith chart, the 4 plus J, that's after you rotated it 180, right?
Yes.
And the 3 over 5 plus J2, that's also after rotating it to 1.
Yes. So this corresponds to this after rotating, and this corresponds to this after rotating. So this
Yeah,
and this.
I'm asking because I barely skimmed through like chapter 10, 11, and 12, so I don't even know how to do this Smith chart.
Now, when I did the
So,
homework, I didn't use the Smith chart, so this is
yeah,
like
so we're learning from scratch right now.
When I
Well,
did the
am
homework, I
at least.
spent 5 hours figuring out how to do the Smith chart, decrypting the freaking stupid book that didn't actually go over anything, and just I hate it.
Yes.
Oh my.
The book
Honestly,
is
bro.
so bad.
Speaking of the
Like,
book, is this any? Sorry.
it's just like, these values that the author got, they got them from their Smith chart, which is different from this one, but they should be pretty it should get you the same answer no matter which one you use. And I'm like, what?
Yeah,
I was like, yeah,
no.
that's useful. Thanks.
I don't know
All right,
what
then.
other EMAG books are out there. I think like Will, remember we were at Raja's office hours and he showed us like his like old EMAG books.
Yeah.
Yeah, they were like from like a while back. It's like black and white, like different like drawings, but it's still like he said it's like a typical EMAC book, the one we have. So yeah, oh well, we got what we got, and we just got to work with it. We're almost done though. Just after
Uh,
tomorrow, we're done.
Is that problem a specific problem in the textbook?
I think it corresponded to one of our homeworks actually. I think it was homework. Let's see, homework 11 or homework 10 was it? Let's see, where was it? Homework 10. I think this might have
It's on
been.
your name.
Yeah, homework 10.
Let me
It
see.
was this one. Yeah, 11.54. Yeah, that was the one.
54.
11.54.
Yeah, you could do it without the Smith chart as well, but it's better you just use the Smith chart.
Yeah, we
Let
should
me
def-
see, bros, because